Hello, everyone, and welcome to 60 Seconds to Code, where I show you how to code in 60 seconds or less. Today's video is going to be more like 60 minutes to code because today we're going to build something, not just some simple programming tutorial. We're actually going to build a chatbot. So let's build a chatbot together. Specifically, today's topic is going to be how to build a serverless conversational experience using Amazon Lex, AWS Lambda, and Python. So let's get into it. On the agenda today, we're going to give you a quick overview of what we're going to be developing and give you some listing of the tools and technologies we're going to be using. I'll give you a quick diagram of the architecture of what it's going to look like, that what we're going to develop. It's going to be simple looking, but you'll get the general idea of what I'm talking about. Then we're going to go into the meat of the presentation, which is going to be the demo. And finally, I'm going to give you some suggested next steps, what improvements you can make and where you can go from here. So let's get started. First, the overview. What we will be building, we'll be building a serverless conversational experience, just like Siri, Alexa, Google, and other chatbots. They can tell you a joke or a random fact. Let me see if I can invoke my Google here. Hey, Google, tell me a joke. So let's see what Google tells me. Why are stadiums so cool? Because they're full of fans. But I'm Tish. This, our chatbot that we're going to be building today is going to be able to do just that. It's going to be able to tell you jokes, tell you a random fact, and our bot that we're going to develop, just like Alexa and Google and Siri can do that, is going to be able to do the same. The tools that we're going to use, tools and technologies we're going to use today is Amazon Lex, Lambda, which is a AWS Lambda. We're going to use our Python, our favorite programming language. Request library, we'll go over that and the different calls available to you in the request library, or whatever your favorite web library might be. Feel free to use that, or even your own favorite programming language. Lambda supports Python, Java, JavaScript, C Sharp, Go, a whole bunch of other programming languages. And we're going to need access to some APIs for our jokes and factoids. So what is Amazon Lex? Amazon Lex is a service for building chatbots, for building conversational experiences and interfaces for any applications using voice and chat. So imagine when you are, think of it this way. You want to build your own Alexa, or if you want to build your own Google bot, or if you want to build your own Siri, well, you can do that using Amazon Lex. It has automatic speech recognition capabilities and natural language understanding. And if you want to know more about that, I will give you a link to the AWS documentation of what Amazon Lex is all about in the description below. We're also going to be, on top of Amazon Lex, we're going to be using AWS Lambda. What is AWS Lambda? Well, if you don't know about serverless, it's time to learn. Serverless is coming, and it's coming with a vengeance. And when it comes to the serverless offerings of AWS, Amazon Web Services Lambda, AWS Lambda is at the core of AWS's compute or serverless compute services, and it lets you run code without provisioning or managing any servers. Think of it as a function as a service. So our evolution was we went from physical servers to virtual servers to containerization, and now we are in this realm of completely serverless architectures. And basically, you can provide a snippet of code to Lambda, and Lambda will run that snippet of code for you. A very simple, basic snippet of code, and you can build very powerful serverless, applications based on that. And where we'll use AWS Lambda, we'll get into that in just a second. We're also going to be using the Python programming language. For those of you who don't know, at least when it comes to if you've been living under a rock when it comes to programming, Python is an interpreted high-level general-purpose programming language, and its design philosophy is amazing in the sense that it emphasizes code readability, and it has significant use, meaning the use of indentation in Python is significant. Where you indent stuff matters in Python. And that's the programming language we're going to be using today. And this is going to be the architecture that we're going to be developing. Let me see if I can find my mouse here. On the left-hand side, you can think of these as the clients who are going to be coming to Amazon Lex via the regional endpoint. Amazon Lex is a regional service, so you can look up the Amazon Lex reference guide for the availability, which region AWS Lex is available in. But you can think of if you have a desktop, for example, Cortana is and Siri are available in Microsoft and Apple desktops respectively. Or if you have a web client, for example, if you are interacting with Google or Siri, you can do it over the web. Or even a mobile client, for example, your Google Assistant or your Alexa Assistant, you can interact with them through through your mobile devices. You can build interactive clients for Amazon Lex using the Amazon Lex SDK for mobile devices, for internet websites or websites and desktop applications. What we're going to be building today is, or what we're going to be focusing on today is toward the right side of this application of this architecture. We're not going to be building any client that you can, if you feel like you doing it, you can integrate it. But we're not going to be implementing any SDK into any client. We're going to be building a Lex chatbot. We're going to be integrating it with AWS Lambda. What's going to happen is the users can interact with Lex using the API calls, and Lex will understand the natural language, pass what was said via the natural language understanding to a response that Lambda can interpret, and then Lambda will make a call to an external API to get the jokes. So basically, our user who's going to be interacting with a desktop or with a mobile or web client is going to say something to the effect of, I want to hear a joke. And Lex will understand that this user intends to hear a joke and will pass that intent over to Lambda. Lambda will then make a call to an API. That API will return a random joke. Then Lambda will translate that into a format that Lex can understand, and then Lex will pass that back to the client. I hope the architecture is simple enough and easy enough to understand. What is not in scope today is Lambda and VPC networking. What that means is that the I've kept this architecture reasonably simple for that reason, that I don't want to go into the details of how Lambda networking and how to give internet access to Lambda, all of that stuff works. Rest assured, if you follow my steps exactly as they are in your own personal AWS account or a test AWS account, all the stuff is going to work. But anything I create today, including the Lex spot or including the Lambda, after you're done creating it, be sure to destroy it so that you don't get any charges. But you shouldn't get much charge because, well, Lex is a serverless service and AWS Lambda is a serverless service. If you leave them on and if they never get called, you don't get charged for them anyway. So let's get into the demo. Let's find my AWS. You know what? Let's start with Lex first, and let's go ahead and go into Amazon Lex and create a chatbot. I've been playing with chatbots a little bit, so I'm going to create my chatbot. What Alex allows you to do is to create some boilerplate templated chatbots for you. You can, demonstrate or see what the chatbot functionality is available for you. And if you feel like doing it for your own exercise, you can do that. But oh, by the way, if you need, I would recommend, go get yourself a personal AWS account. But remember, any resources you create in your personal AWS account, I'm assuming with this tutorial that you already have a personal AWS account, but anything you create in your personal AWS account, be sure to destroy it after the fact. So let's go ahead and create a custom bot. Let's call it jokes and facts bot. And this bot, it's only going to be doing two things. It's going to be telling jokes and it's going to be telling random facts, facts plural bot. And the language that we're going to select is American English, and AWS Lex supports multiple languages. You can find the listing of the supported languages in AWS Lex's documentation. And here I'm just going to choose one of the
Hello,
random
my name is
languages. And if you
Sally.
feel like we want to hear hello, how are you? I don't know if my speakers are going to pick this up,
Hello, how
but
are
I'll
you?
say this text in
Hello, how are
Sally's
you?
voice. So I don't know if you guys can hear it, but
Hello,
Sally's
how
saying
are
it.
you?
All right, let's say session timeout is going to be let's keep it at the default 5 minutes. We don't want any sentiment analysis. This is kind of a little bit out of scope for this one, but you can use Amazon Comprehend for performing sentiment analysis, meaning if a user is getting frustrated, etc., you can integrate sentiment analysis to your chatbot. In our case, we're not going to do any sentiment analysis. Copa, AWS. Oh, by the way, yeah, I am role for AWS. This is the role with which this under which this AWS chatbot is going to be running. And if you are making any calls to, by the way, the default IAM role should be just fine, and it will be automatically created for your on your behalf. And this is all that you should need at least for today's demo. China COPA, China, not China, online children's online privacy protection act. This chatbot is not being created for any children, so we're just going to say is not subject to COPA and any advanced options accuracy improvement. We're just going to say no here, and we're going to go ahead and create our chatbot. So Lex has created a chatbot for us, and we're going to first get started by creating an intent. Now, an intent is exactly what it sounds like. It is what the user intends to do. Now, what do I mean by that? When a user wants to hear a joke, what do they tell Google, or what do they tell Siri, or what do they tell Cortana? They say, Google, tell me a joke, or Cortana, tell me a joke, or Siri, tell me a joke. Well, in our case, we're just going to say, this is the joke's intent, and this is what the user intends to do. And the sample utterance, what the user is likely to say. This is the first thing that you have to fill out the conversation and understand it's a natural language conversation. What is the user likely to say in order to invoke this joke's intent? Is he likely to say, I want to hear a fact? No, the user is likely to say, I want to hear a joke. Or they might say something to the effect of, please tell me a joke. Or they might say, can you tell me a joke? Things like that. You can create as many sample utterances as you like, but I say 10 to 15 should be enough to train your chatbot. But I would recommend be on the lookout for any failures that are occurring within your uh, CloudWatch alarms to see if users are trying to invoke intents that, or at least use utterances that you hadn't thought of in order to put some sample utterances. But if you put 10 to 15 utterances using natural language understanding, Lex will be able to, even if you didn't put a sample utterance that's, or even if a user utters something that you didn't put in here, Lex will understand. And Lex will make the generalization that the user is looking to, because there can be almost unlimited ways of, saying one thing. So now we have three sample utterances, with which the user who is intending to hear a joke can say, with which this joke can be, this intent can be invoked. We're not going to do any Lambda initialization and validation, even when you are working with Lex, even when you are starting. You can immediately, any input that the user receives, you can immediately initialize that input or validate it via Lambda. In our case, we're not going to do that. We're going to leave this collapsed. But what we are going to do is we're going to ask the user for a particular slot or a particular slot type. We're going to create a slot type. Now, what do I mean by slot type? Whenever a user is interacting with any chatbot or any online automatic chatbot, I'm assuming, or I'm sure you have interacted with online chatbots that, for example, tell you about your reservation or help you book a hotel or help you book a flight, etc., or give you a status of your case. They ask for certain key pieces of information in order for them to be able to fulfill that intent. So if you say something like, I want to check the status of my case, that's your intent. The chatbot might ask you, what is your case number? And that case number that bot is asking you for is a slot, meaning it's a key piece of information that the bot requires in order for them to be for the bot to be able to understand and fulfill what you're intending to do. In our case, we are going to do a very simple slot type, and this type of slot that we're going to create is going to be, we're going to call it a joke type slot. Now we're going to be supporting two types of jokes. We're going to be supporting Chuck Norris jokes, and we are going to be supporting dad jokes. Those are the two types of jokes that we're going to be supporting today. That Notice that synonymously, somebody might say, I want to hear a Chuck Norris joke instead of just saying Chuck Norris. Or they might say something to the effect of uh, Chuck joke, or oops, or tab Norris, or uh, Norris joke, or tell me a Chuck Norris joke. These are synonymous to, or the type of information, the information that the user is trying to say is actually just Chuck Norris. These are different ways of saying the same thing. And the same thing we're going to say Chuck Norris, not dad jokes, just dad, and say, the user might also say dad joke, or dad joke, or let's say dad joke, or something to that effect. And we're going to go ahead and save and add this slot to this intent. Now, the name of this slot, we're not going to call it slot one. The slot type obviously is going to be the joke type, or we're going to call it joke type as the name of this slot that we're trying to fill. By the way, you can use the slot type in multiple intents, and you can use this slot type. For example, if you've created a slot type for case number or social security number or something to that effect, you can use your slot types across multiple intents. So you can use the same slot type. In our case, this is a required slot, meaning that whenever a user wants to fulfill this joke's intent, we're going to make them enter or tell us the type of joke that they want to hear. So we're going to go into the settings for this particular slot. And this is the prompts that, for example, do provide a default value for a context value or variable for session variables. We're not going to provide any default values, but we're going to provide some sample prompts. So a user, whenever, let's assume for argument's sake, the user does not provide a type of joke, the bot is going to prompt the user with, what type of joke would you like to hear? Or because this type of joke or this slot is required, they might say, what type of joke? Or the bot might respond with, tell me a joke type you would like to hear, so on and so forth. And now, obviously, this is the default, prompt that the what city it came up that Lex came with it by default. But the maximum number of retries, we're going to leave it at 2. But the conversation is going to go as follows. When the user says, I want to hear a joke, and does not tell, or at least in the immediacy of the intent, does not say what type of joke, and because we're requiring the joke type to be an information that the user has to tell us, the bot is going to respond with, tell me a joke type you would like to hear, or what type of joke would you like to hear, etc. And then the user might respond with the following information, a joke type. So for example, they might say a dad joke, or a Chuck Norris joke, or a dad joke, please, or a Chuck Norris joke, please, or something like that. Or the user might say, please tell me a joke type joke. Or they might say joke type joke. So this is the natural conversation that we're building between the user and the bot. What the user is going to be saying, tell me a Chuck Norris, or please tell me a dad joke, or please tell me a Chuck Norris joke. Or the user might say dad joke, or Chuck Norris joke. Or the user might say a dad joke, or a Chuck Norris joke in response to when the bot asks for the joke type that the user wants to hear. But also notice that now that this slot is required, we also have to understand we have to go back and edit or enter some sample or utterances where the user might just say the joke type that they want to hear within the opening intent or within the sample utterance, the opening utterance. So for example, they might say, can you tell me a dad joke? But notice the problem. We're hard coding this, but the user might not say dad. The user might say, can you tell me a Chuck Norris joke? So we can use curly brackets and type joke type as the slot that the user might invoke here. We're going to add to the sample utterances, and notice it became blue. What this does is it tells the chatbot that, can you tell me a Chuck Norris joke, or can you tell me a dad joke, is a sample utterance that the user might say in order to invoke this intent. And the user might also say, tell me a joke type joke. That might be a sample utterance that the user might say. But in this case, the joke type slot is required, but this time the user should not be prompted for the type of joke because the user has already stated the type of joke they want to hear, but then they're invoking utterance. So this should be good. We have three sample utterances in which the user does not tell the type of joke they want to hear, two sample utterances in which the user tells the bot the type of joke they want to hear. And in our case, at least to start with, we're not going to do our fulfillment with the AWS Lambda function. We'll come to that in just a second. We're just going to return the parameters to the client. So what does that mean? When this API is called and whenever the SDK is called and this particular slot is ready for fulfillment, it just return. It does not do any smart processing using AWS Lambda. Just returns all the parameters that this is the joke, or sorry, this is the intent that the user tried to invoke, and I am ready to fulfill it, and it passes that information back to the client without doing anything with it. We will integrate AWS Lambda with this in just a second, but this is, we have created our jokes intent for now. And let's go ahead and save this intent. And for our jokes and facts spot, our first intent is done. Next, we are going to create another intent. We're going to call this the facts intent. And this time, we're not going to have any sample slots or any sample slot types. When instead, the way that the user might invoke this intent is say, tell me a random fact. Or they might say something like, tell me a fact. Or they might say something like, tell me an interesting fact. Something like that. We have, like you said, there could be any number of ways that might invoke this intent. But the rough rule of thumb is if you use 10 to 15 sample utterances and the different ways in which this utterance is likely to be invoked by the user, Lex, even if the user says something that you have not specified in the sample utterances, Lex is pretty good at extrapolating what the user intended to say. We're not going to, again, invoke any Lambda function or integrate any Lambda function here. We're just going to return the parameters to the client. And let's go ahead and build. Now, what build does is if in case you made any mistakes, basically it's a way of pre-compiling or compiling the chatbot to make sure that if there is any slot information that you missed, if you made any typos, if you typed anything incorrect into your bot, that your bot first will build. Basically, it's almost that it compiles, and notice that my bot build was successful. And now I can test my chatbot. So let's see if I can test it with the microphone. Now on the right hand side, I'm going to collapse it for a second. Um, this test chatbot is the integrated Lex test panel, and here you can chat with the chatbot you built, or you can even interact with the chatbot you built via voice. So I'm going to try to do it via voice. The last time I tried it, it didn't work, but let's hope that it works this time. I'm going to say allow and say, tell me a joke.
Tell me a joke type you would like to hear.
Notice that as soon as I told it, tell me a joke, say, okay, what it asked, immediately responded with one of the sample utterances that, hey, I need to know the joke type that you would like to hear. So I'm going to say dad joke. And you say, notice it immediately says the intent joke intent is ready for fulfillment, and the type of joke that this person would like to hear is a dad joke. And again, I'm just going to say chat this time. Tell me a joke and say what type of joke would you like to hear. And this time I'm going to say Chuck Norris joke. And notice this time it's the joke intent, it's ready for fulfillment. And the type of joke that this person would like to hear is the Chuck Norris joke. And I'm going to say, tell me a fact. And notice that this time, because the fact intent did not have any required slot type, it immediately understood that this person is intending to hear a random fact. So this chatbot is actually now ready for prime time. I'm not going to publish this chatbot. If you want to know more about how to publish your chatbot so that it can actually, be integrated with your client applications, etc., I'll provide you a link to Amazon Lex. But for now, our chatbot, or the two intents and the utterances and slots that we wanted to build into our chatbot, is ready. It's ready to do three things. Actually, two things and one conditional thing. The first thing, the joke's intent, it's ready to tell us a joke, and it's ready to tell us a type of joke. It's ready to tell us either a dad joke or a Chuck Norris joke, or it can tell us a random fact. That's what it's ready to do. But right now, as you notice, it's not really doing anything smart at all. As soon as I say what type of joke, it just, uh, returns the intent back to the client and say the what the user wanted was he wanted to hear a Chuck Norris joke, and the user wanted to hear a random fact, and it returns all the parameters back to the client. Well, technically, what we would like to do is we would like for AWS Lambda to be able to tell jokes, to be able to basically we want this chatbot to be able to tell jokes, and this is where we're going to integrate our AWS Lambda function with our bot. So let's go to our AWS Lambda tab, and I'm going to go to my functions, and I'm going to create my function. Now, again, AWS Lambda is a serverless compute service by AWS. I'm going to call my function, uh, let's call it jokes and facts function. Okay, that's the name of the function that we're going to call it. Our runtime that we're going to be writing our code in today is going to be, like I said, our favorite programming language, which is Python. We're going to say Python 3.7. That's going to be our runtime. We're going to leave the rest of, actually, let's see if Python 3.8 is supported. Yeah, Python 3.8 is supported, latest supported. So let's do Python 3.8 instead. Uh, we okay. So for those of you who don't know, if you need to invoke any additional AWS services with the execution role for this particular Lambda function, you can you can create a role and basically give that role permissions to other AWS services, and then this Lambda function will be able to invoke those AWS services for you. But for our purposes, the default execution role, which will only have basic Lambda permissions, will be more than enough. So I'm going to go ahead and click create function. And while it's creating the function, let's see. Okay, the jokes and facts function has been created. So I have some starter code that I wrote in the Lambda code py. And this is basically the first iteration of what we're going to be doing, and I'm going to go over this code in just a second. So we're going to go to lambda function.py, and every lambda function that comes this Python comes with a basic lambda event handler. So we're going to override the basic lambda event handler, and we're going to go through each of the lines of this code right now. I'm just going to go ahead and replace all that stuff with my own code. Now, notice that I have written three different helper functions. We're going to come to these three different helper functions in just a second, but I have rewritten the Lambda handler function a little bit. Whenever the AWS Lambda function is called, the object that gets, or the basically the payload that comes, it comes in the event object. The context object tells, for example, about the Lambda running environment when the Lambda function was invoked, etc. Basically, the context object contains everything you need to know about the Lambda function itself. The event object tells you everything you need to know. Basically, this is the payload that uh, uh, whatever service is calling the Lambda function, that payload that gets sent in the event object. So that's what the event object and the context object is going to be about. So let's move on. This is the response that we need to build in order for Lex to understand at a bare minimum what to do with this particular response. If you want, you can read AWS Lex's developer documentation. But what I have created is a bare minimum response that AWS Lex expects from Lambda in order to be able to understand or in order to be able to do what we're trying to do. So basically, what we're going to do in this case is we're not going to do anything fancy. We're immediately going to close the dialog action and we're going to consider the intent to be fulfilled. And what we're going to do is we're going to give a response back to Lex stating that the content type that we're sending you back is plain text. And the only other thing that we're going to add to this particular response object that is that remains to be populated is going to be this content property of the dialog action message. So response.dialogaction.message has to have a content property. And that content property is where we're going to populate what the bot is going to say back to the user. So what just for the purposes of testing and for you guys to see what I'm doing, I'm going to go ahead and print the event right here. And within this, what I'm going to say is if within the event object, which is what Lex is going to pass on to Lambda, if within the event object, the current intent name is the fact intent, what I want you to do is I want you to, within the response object, which is the dictionary right here, sorry, I keep calling it an object, but it's actually a Python dictionary. Within the response dictionary, within the sub dictionary dialog action, within the sub dictionary message, I want you to add another key value pair, key being content, and the value for that content property, I want you to execute the random fact function to get that random fact. So this is where I declared the helper function. Now, when this particular intent is going to be the facts intent, whenever the user invokes the random facts intent, this helper function is going to get executed. And the only thing, because this is, this is just, where did my, I think this might fail because I think I've neglected to do a JSON import. So yes, I think there might be a mistake. So I did not. Let's do a JSON import up here so that, yeah, so that it does not fail. Moving on. Now, there there are two types of intent that this particular function or this particular chatbot, not sorry, not function, that this particular chatbot that we're writing is going to be able to support. The first one is going to be the facts intent. And if the user invoked the facts intent, they're going to go into this function and it's going to get this fact, this random fact. Now, every time this random fact intent gets invoked, it's just going to return this one random fact. That's not very interesting. We will change that in a bit. But the second type of intent that a user is likely to invoke is that they might invoke the jokes intent. And if they don't invoke the facts intent, the only other intent that we are going to be supporting is going to be the jokes intent. So we're just going to put it in a singular else clause. So if the event current item in current intent name is facts intent, then we're going to send them a random fact. Otherwise, we know that it's going to be the user is going to be looking to be told a joke. So then we're just going to check if the slot or the joke type slot is Chuck Norris. And if it is Chuck Norris, then we're going to populate the content of the message, or sorry, the response item that we're returning. We're going to make a function call to the Chuck Norris helper function. And this Chuck Norris helper function is going to return this Chuck Norris joke. Chuck Norris does not do push-ups. He moves the earth up and down. Otherwise, if the joke type is not Chuck Norris, we know that the only other joke type that we're currently supporting is a dad joke, which is the other else case, which is going to be the response dialog action message content. We want you to return a dad joke. So let's take a look at the dad joke helper function, and we're going to return, what do you call a man with no body and no nose? Well, nobody knows. That's the dad joke that we're going to be returning. And then finally, based on this condition, based on whatever the user was attempting to invoke through the Lex, this response object have message item, message dictionary, message object is going to contain this content key, and the value, depending on what the user invoked, is either going to be a dad joke, a Chuck Norris joke, or a random fact. And that is our Lambda function. So let's go ahead and test this Lambda function before we actually, invoke it from Lex. So Control A, Control C. Let's go back to test, and let's configure a test event, and let's call it, uh, you know what? Let's call it Chuck. Oops, Chuck Norris event. Now, what we're going to be doing is we're going to be passing the current intent. And notice the current intent is going to be joke intent, and the joke type that the user is going to be invoking is the Chuck Norris joke. So let's go ahead and create this as one of the tests that we're going to be testing our Lambda function with. But this is not the only test event that we're going to be testing our function with. We also need to create another test event for the dad joke. So we're going to call it dad joke event. And in this case, the current intent is still going to be the joke's intent, but the joke type is no longer going to be Chuck Norris. The joke type is going to be a dad joke. So let's create this test. So now we have two tests that we can create. And now the final test, the third test that we're going to do, is going to create a new test event. And in this case, the current intent is not going to be jokes intent, it's going to be the facts intent. And obviously, when you're invoking the uh, in, the facts intent, there is no joke type, so we're good with that. So let's go ahead and, oh, by the way, we have to name this. So we're going to say facts intent, facts event. In the event that the user intends to hear a joke, hear a Chuck Norris joke, or a dad joke, or a random fact. So let's go ahead and test our function with the Chuck Norris event. And let's, oh, by the way, I have to save and deploy. That test is not going to function. So I'm going to go ahead and deploy my changes. My changes got deployed. And let's click the test button and see what happens. And notice that our function got called successfully. And it said Chuck Norris does not do push-ups. He moves the earth up and down. That is what we expected, because our event that we're currently testing with is the Chuck Norris event. Let's go ahead and test it with the dad joke event and run the test again. And notice this time it told a dad joke. What do you call a man with no body and no nose? Nobody knows. But no matter how many times you run this particular Lambda function, it's going to keep returning the same thing over and over again. That's fine. For the purposes of testing, it's sufficient. And finally, just for the sake of completeness, let's run a facts event and go ahead and test that. And notice that as soon as we said the facts intent was we want to hear a random fact, it executed the facts random fact function and told us a random fact. Okay, we are good to go on our function. Let's go ahead and copy the name of the function. And our function is now ready to be integrated with Lex. Go back to Lex. Whoops, no, I did not need to do that. Go to Lex, and now this time we are not going to, we're going to, after the jokes intent and the facts intent is ready for fulfillment, we're not going to return the parameters to the client. we're actually going to invoke a Lambda function. And the Lambda function that we're going to be invoking is the jokes and facts function. And you say, you're about to give Lex permission to invoke your Lambda function. I'm going to say, okay, yep, that's what we want to do. And we're going to go back to the facts intent, and we're going to do the same thing. And I'm going to say the Lambda function I want to invoke is the jokes and facts function. And again, it's going to say, you're about to give Lex permission to invoke your Lambda function. Are you sure? I said, yes, I'm sure. Okay. Let's go ahead and build and give it a minute while it builds. Again, it's like a method. You can think of it of a way of compiling the code to make sure you haven't done anything wrong or done anything wrong or typed anything wrong within the intents or anything in relation to your Lexbot. Let's give it a minute while it's ready. And now the jokes and facts bot was built successfully. This time I'm going to say, tell me a joke. And again, as usual, because I did not tell it what type of joke I want to hear, it's going to ask me, what type of joke would you like to hear? I'm just going to say that joke. And when I say that, notice now it's telling me the jokes that I've specified within my helper function. It's going into the dad joke and retrieving the dad joke. Now let's go ahead and ask it to tell us a Chuck Norris joke. This time let's try to invoke it with the microphone. Tell me a Chuck Norris joke.
Chuck Norris does not do
Again,
push-ups.
very
He
nicely
moves the
done.
earth
It
up and
understood
down.
the text, sorry, not text, the speech that I spoke, and it knew that because I already told it that tell me a Chuck Norris joke was the joke type slot, and it understood that the Chuck Norris was the type of joke that I wanted to hear. It invoked this joke's intent and fulfilled that intent by using that Lambda function. And let's finally try tell me a random fact.
We are
We
13.7
are
billion
13.7
light years
billion
from
light
edge
years
of the
from the edge of
observable
the observable
universe.
universe. Okay, now our Lambda function and Lex bot are integrated with each other. But we're not done yet. The reason we're not done yet is because our Lambda function, yes, it's telling a Chuck Norris joke. Yes, it's telling a dad joke. Yes, it's telling us a random fact. But it's telling us the same random fact, the same jokes over and over again. Let's get a little more dynamic, shall we? Here is what we're going to do. We're going to go to our Lambda code py and get the new and improved version of the code and put that into Control C. And let's go to the Lambda function and replace everything that we got with our new code. Excellent. So let's see what's going on. We're going to be using some helper functions from a helper library, and this is called the request library. The request library is a library. Whoops, I don't know if I got out of the frame. The request library is a third-party library that you can download via pip install, and it allows you to create get post requests from in Python very easily. So basically, now with Lambda, you can integrate any third-party library. We're just going to import the request library. Now, the changes that we've made to our three helper functions, the Chuck Norris joke function, the dad joke function, and the random fact function are as follows. We're going to invoke this Chuck Norris API. I found this API on the internet. And when you invoke this via this random URL, it returns a JSON response. And within the value field of that JSON response is a Chuck Norris joke. So I found a random Chuck Norris joke API on the internet, and every time now this Lex function, that Lexbot invokes this Lambda function, and the user's intent is going to be the Chuck Norris joke, is going to fall into this our helper function, and what we'll do is it will try to fetch this particular random Chuck Norris joke from this particular API call using the request object, and it'll turn into JSON, and then it will return the value that will return the data, which is where the Chuck Norris joke, the text of the Chuck Norris joke is going to be back to our Lexbot. And it's the same thing with the dad joke. The API call for the dad joke is slightly different. Sorry, my nose is a little bit itchy today. The dad joke call is a little bit, oh my God. The dad joke is a little bit different. You have to get the URL, you have to provide some headers, and basically, if you just do a simple get, I think it returns HTML. But if you the type of if you want to accept application or JSON only, then you have to specify this header value. This is where the request library comes in very handy. I didn't need to write any of this function. I imported the request library. It's creating the request object for me. It's doing the work for me. And finally, again, within this joke, within the dad joke API, the joke itself is actually returned in the joke object, but in the Chuck Norris API, the joke is returned in the value property of the data object. And same thing with the random fact. We're going to try to call the random fact API that I found on the internet. We're going to make a call, and this time the data that or the value of the random fact is not actually found in the value or the joke field is actually found in the text field of the data object that is returned from this get call. Now, why did I do a try catch statement? Well, you can probably understand. API can become unavailable, or it might happen that this API is no longer available, or even for the purposes of forcing this thing to fail. What I'm going to do in just a second is I'm going to replace or delete one of the T's to force this accept block to occur. But basically, you want to create a try catch or try accept block. Obviously, you want to try and accept. Make sure don't create a blanket accept statement. Try to catch particular exceptions. But in our case, or at least for the purpose of building this test bot, this should be sufficient. Um, what if this particular API call fails? I want you to do something. In our case, what we're doing is we're going to fall back to our classic Chuck Norris joke that everybody knows and loves. But when you are in a production environment, this is when you want to wake up your operations team and be like, hey, that nice API that everybody's depending on, that your function depends on, that your Lexbot depends on, it's no longer working. Get to it. So this is where your accept block is the purpose of this try accept block. And I've put it in all three of my, but the rest of the function is pretty much the same. There's nothing else changed here. Again, when a random fact is asked for, it invokes the random facts function. If when a Chuck Norris joke is asked for, it asks the Chuck Norris joke function. If a dad joke is asked for, it invokes the dad joke function. Now, this is not going to work. You must be thinking all that talking and so much work for it to not work. Why wouldn't it work? Well, here's why. The request library is actually not available as an import. This import statement simply will not work. For those of you who are familiar with Python, if you want to use a third-party library, what do? Well, you do a pip install, right? A pip3 or a pip install, and you get your Python library installed, and voila, you're on your way. So let's do a pip install. Remember, AWS Lambda, there is nowhere to do a pip install. You know why? Because Lambda is serverless. There is no Linux or a Windows server where I can do a pip install. So now if I were to, attempt to test this particular event, the reason we got, hang on one second. Oh, I never deployed it. That's my problem. I never deployed it. It was running the older version of the Lambda function. Now, if I attempt to test it, I get an error message. What's the error message? I'm unable to import module, no module name request. Now, obviously, what do? Can I never use any third-party libraries? Well, this is where Lambda Layers come in. So I'm going to go ahead and save this function. And I'm going to go back to Lambda. And I'm going to find layers. I've already added a few layers, the pandas layer, the numpy layer, the 2py layer. I was, playing around with Lambda. But here is where I'm going to add the request library as a layer. So a few downloads, and I'm going to create a new folder here. I'm going to call it, whoops. So what I'm doing right now is I am creating a folder structure where I'm going to install the Python request library. This Python folder is basically a standard convention in which all your requests, sorry, not requests, all your third-party libraries need to go that you want to package into a Lambda layer. In our case, it's just going to be the request library. So this is where we're going to install the request library. So I'm going to go ahead and launch cmd.exe from here. And we're going to do a pip3 install requests library, and we're going to target the current folder. Dash T is the target flag, and period means I want to target and install the request library into the current folder. Let's press enter. Okay, and now it's going out there, getting the uh, request library and installing uh, the request library into the current. Okay, let's see if that succeeded, and looks like it did. We have our request library in our Python folder in our downloads folder. So let's go ahead and, by the way, I know I'm going a little bit fast for because I'm getting way over time here. I'm going a little bit fast for the purpose, but if you want to know how to, package your code up into a layer and introduce it into your Lambda function, I'm going to give you a couple of links below. You can do what I just did. So now I'm just going to go ahead, right click on this Python folder, say send to a compressed zip folder, and I'm going to call it, after it's done compressing and zipping. I hope it doesn't make a liar out of me. Well, I already have a requests layer, so probably use that. But just to be safe, if the package or nothing got I'm just gonna call this. Ah, it's not working. It's still compressing. What's going on? There we go. I think that worked. I'm gonna call it requests. And now we have a zip file that we can upload to Lambda. So let's go ahead and create a layer. We're going to call my layer requests layer. And we're going to upload a zip file. And it's best practice to always upload your requests or any third-party libraries to Amazon S3. But for the purposes of this demo, I'm just going to upload it directly. I'm going to find it in my downloads and requests. And I'm going to say runtime is going to be Python 3.8 and create. Here we go. Give it a second while it creates the layer, and there is our requests layer. So now we have 4 layers. We have the NumPy, Pandas, TweePy layer. We just added ourselves a requests layer. So let's go ahead and find our function. Whoops, come on. It's taking its sweet time, and find jokes and facts function. And oh man, it's late at night, and it's starting to test my patience. I think my internet's slowing down for some reason. I hope my recording doesn't go haywire. That's almost an hour worth of work down the drain if that happens. Okay, so now we have our Lambda function, and if we click test, it still fails. Why? Because even though we have created a layer, we have not made our Lambda function aware of the existence of that layer. So we're going to go down to the layers section. We're going to say add a layer, and we're going to say add a custom layer, one of the custom layers that we've added. We're going to find our requests layer and call it the first version. By the way, if you're interested in creating Lambda layers, versioning them, etc., and the details of it, I will provide a link of all of that in the description below. I'm going to click add. And now we should have, if because last time I tried it, my zipping or something to that effect did not work properly, and my layer did not get created correctly, and it would not work. Let's hope that this time it worked. Let's go ahead and attempt to test our Lambda function. And oh, this time it worked. This time it worked. Notice Steely Nan got their name from the sexual device depicted in the book The Naked Lunch. This is the facts intent, the random facts intent. Let's attempt to get a random dad joke. See if that works. I thought my wife was joking when she said she'd leave me if I didn't stop signing. I'm a believer. Then I saw her face. What do you do on a remote island? Try and find the TV island it belongs to. Let's go ahead and do a Chuck Norris joke test. And Chuck Norris can repaint the Mona Lisa with no paint. Yeah, Chuck Norris is the man. Test another Chuck Norris joke. Danny DeVito used to be over 7 feet tall before his Chuck Norris pile driver. So there you have it. Now, this Lambda function is not just returning our canned, you know, responses. It's actually returning real jokes. But in our case, in order to, let's go ahead and for the purposes of completeness, let's break the URLs and deploy the code. And this time, it shouldn't break, but it should fall back to the default stuff. The reason is that this HTTPS, that should not work. So if we go ahead and click test, it will give us our default Chuck Norris joke. It gave us our default dad joke, and it gave us our default fact. So let's go back to the Lambda function, fix our URLs, to not no longer make them fail. Whoops. And where is the third one? There is the third one. And let's go ahead and deploy. And let's test our Lambda function a couple of times after deployment. What's going on here? The electric chair was invented by a dentist. That is a random fact, random Chuck Norris joke. There you have it. Now, let's go back to Lex. And let's see what happens now if we ask for, tell me a Chuck Norris joke.
Chuck Norris was the first superson.
Chuck Norris was the first Super Saiyan. Tell me a dad joke. For some reason.
Whiteboards are remarkable.
Whiteboards are remarkable. For some reason, my mouse is right clicking instead of left clicking. Tell me a dad joke.
My son is studying to be a surgeon. I just hope he makes the cut.
Oh, because I was talking and I clicked my mouse a little too early. It caught the conversation. But notice, even though I invoked this intent with some complete random gibberish, it still was able to extrapolate that I'm trying to hear a dad joke. Tell me a random fact.
Donald Duck's middle name is Fauntleroy.
Donald Duck's middle name is Fauntleroy? I did not know that. I did not know that at all. And there you have it. We have built a Amazon Lexbot that is talking to Lambda, that is using the request library and is making calls to third-party APIs to get jokes and facts. That was our demo. So what are some of the next steps? Now, first, I'm going to ask you some question. Do you think it's a good idea? Because in my code, by the way, I will provide a link to the code in the description below and to my Git repository. But do you really think that it's a good idea to store the URLs of your API calls directly into your Lambda function? It's not. It's a terrible idea. Consider using the following. Look up how to, read values from OS environment variables in AWS Lambda, or bonus points if you are able to integrate either Secrets Manager or Systems Manager parameter store into your Lambda function. Much more secure, much better. Also, do you think it's a good idea to use a single Lambda function for everything? In our case, we were using the jokes and the facts in a single Lambda function. The reason is that you might want to, pay or find out which intent is being invoked more frequently, which function is being invoked more frequently. And it's best practice to make your functions as atomic as possible, as small as possible. One function, one purpose. And you have one function that is fulfilling both purposes or both intents at the moment. The one function is telling you jokes, and the same function is telling you facts. Split them. That is, try to do that in your, maybe create a different function for jokes and a different function for the facts. Also, do you think you would want to import the entire request library? Because if you read my code, I would encourage you to do so. We only use the get function. So do you think it would be a good idea to blanket import the entire request library? Perhaps we only want to import the get function from the request library to save on some of the costs. And can you integrate any line of business system or API calls into your Lambda function? So for example, try to create a bot that can give you a status of the case or a status of a case, and basically create a data dip by making an API call to either Dynamics or Salesforce and get a data dip and get the status of the case that the user asked for. So basically ask the user for the case number and create a slot type called case number, and then request the user provide the case number and then pass that case number back to your API call, and then from that API call return a case status back to the Lambda function, and then Lambda function returns it to Lex. This will give you the entire breakdown. Okay, those are some of your next steps. Have fun doing that, and as always, thank you very much. That today was what we did was we created a conversational experience. We created a chatbot using Amazon Lex, Lambda, and Python, and the request library. If you have any questions, comments, please leave them below. I will see you next time. Talk to you later.